Greetings, everyone. Today I'm going to talk about AI, artificial intelligence, usage in predicting thermal comfort, as well as its impact on building control and thermal comfort. Traditionally, we use Fanger's method for thermal comfort, but using AI, we can use a nonlinear algorithm, and also we can predict the relationships, which are much more complex between occupants and their environment. PMB has been largely used which was introduced by Fangers, but it's also being criticized because it was developed in a experimental chamber with steady state, which is not so real in the real situation. And also it was tested on healthy adults, which is not representative of everyone, because we also have younger adults like kindergartens and children, as well as older adults, senior citizens who have different comfort criteria. That's why AI becomes important here, because we can include different and more aspects of human comfort. Traditionally, comfort was considering 6 factors in PMB, which 2 of them are personal data and the others are indoor environment, which is indoor air temperature, radiant temperature, indoor air velocity, humidity, and insulation and metabolic rate, which is personal. Later, there came different adaptations of PMB, like APMB and EPMB, which APMB is the adaptive approach. It goes beyond physical parameters, and also it just consider outside temperature. We also have EPMB, which is extended PMB, and it could include local climates, typical local climate data, like historical data as well. But what is AI? AI is the ability of machines who can perform like humans, like we could teach them, and they could learn, and they could predict what could happen. There are different type of logics. One is machine learning algorithm, and also fuzzy logic. In fuzzy logic, it's as contrary to Boolean, which Boolean we only have yes or no, like in C++ we have just black and white, just 2, but in fuzzy logic there is in between, so you have probabilities of in between, like maybe between 0 and 1, then you have 0.5, or if it's a logic of cold or not cold, that would be in Boolean logic, but in the fuzzy logic would be a little bit cold, not cold, a little bit hot, so you have all the in-betweens in fuzzy logic. And in AI learning, there are different methods of learning. There could be supervised learning, unsupervised learning, and reinforcement learning, which nowadays most of the studies have been done. They're all under supervised learning, which is not so favorable, because there must be always a human who's overlooking at them. We need more unsupervised and reinforcement learning in this study. This is somewhere that we can go, and there is area of work here that scientists could work on more. So we have different methods of learning. Here also we have different types of learning algorithms. Most common is ANN, which is artificial neural network. And also we have decision tree or random forest. We also have support vector machine learning, k-nearest neighbor learning. There have been a lot of studies using all these algorithms in human comfort studies. For example, there have been some studies by Moon which use outdoor air temperature or solar radiation to train and develop artificial neural network to predict the indoor air temperature. So um, with a certain data of outdoor temperature radiation, it could predict what will happen in another case for indoor temperature. And there have been numerous studies that they have input outdoor temperature, cavity temperature, solar radiation, window opening condition, and their output would be to predict indoor temperature. We have also been studies to find out the set temperature. They are all using AND method, neural network prediction. Some of the problems with this method is that there will be inconsistency in types of variable used. For example, if you use the same learning in another case with in a similar situation, they might have a different result and our result might be insufficient. Another method that was highly used was decision trees or random forest, which in a study by Chaudhuri, he developed a random forest algorithm to estimate the thermal sensation, like PMV, but it was using more than a physical environment. And it was also using physiological measurements like blood oxygen saturation, blood pressure, and pulse rate, as well as the skin temperature, besides all the environmental variables like relative humidity and velocity. And he could report that the thermal sensation had an accuracy of 92% and 94% for female and male subjects, which is much higher than normal PMV accuracy, which I think is around 34 or 35. There have been also more studies by Wang about, he did these studies on elder people, like senior citizens, and also using a random forest model to predict their comfort. He also reported an accuracy of 76% rather than traditional PMV method. And normal PMV, also it was higher than normal PMV method. One of the best part of these methods are they have higher accuracy than a normal PMV model. There is just one place that we could improve, and that would be in building control in HVAC systems. There is a lack of studies in connecting thermal comfort with control systems. Well, we could save a lot of energy if we could relate these two. So for the scientists, there is a gap here that could be used highly. So using all these random tree methods, there has been a lot of studies calculating PMV and also TSV. They take different factors like human metabolic rate or carbon emission and illuminance, different factors have been studied. So far, the studies that have been done, they take this normal 7 steps. First, they will identify the building, whether it's office or residential. Also here, I can mention another gap is that most of this is study being done in office buildings, not really much in residential, and that could be because it's hard to measure people's comfort in residential buildings or gather the data because it needs a lot of intense work. So there is a gap for residential buildings. Also, step 2 is to collect data, but in step 1, we could improve also people's comfort in the daytime, but there is no data about sleeping people and their comfort during night when they're sleeping. So these are the three gaps in step one that could be improved. And step two, which is collecting the building data, climate data, and operation information, there are insufficient amount of data, and also some of them are biased, so that could be improved. And it's difficult to envision about these systems. Maybe government agency need to support and improve the data that we have and gather large scale data, for example, a block of building rather than individual people gathering data. And also we can incorporate new technologies like supervision and streaming data is important. We can use them for prediction. Even though bias are inevitable, but they will end up giving us inaccurate outcomes for these models. And in section 3, step 3, we need to choose learning technique based on types of collected data. So most of the data here are supervised. We need to work on more unsupervised and reinforced data. As we mentioned, we need many of studies conducted in actual building, but we need it to be run by itself and also work on energy consumption rates and its reduction. In step 4, we can choose the model. As you see, there are so many types like random forest or ANN, but choosing it is very hard because there is no generalized way to say which one you have to choose, and there is no rule. So we cannot generalize the code. Okay, for the example, for PMB, you should use this algorithm. There is no such generalization method, and it's a very individualistic approach. So there is a gap to improve how we can generalize this and come up with a single method of one algorithm that is used for all data, so it's more consistent. In step 5, training and validation of the model. While the variety of parameter tuning techniques and optimization techniques that already exist for machine learning model are beneficial, they can also lead to an inaccurate and unnecessary expensive work, which is maybe improper. And there remains a need for a study to explore optimum parameters, turning to optimization techniques that consider both accuracy and computational cost simultaneously. And in step 6, integrating the model in a building control system like HVAC systems, which is also a big gap. There is a lot of studies in the use of AI in thermal comfort modeling. And also it's proven that AI has this ability to predict thermal comfort. As compared to traditional, it's much more accurate. But the development of such models is not discussed for building control system. And therefore, in the future, there is a place to emphasize a discussion regarding the integration of AI predictive model into building energy management systems. So that could be very impactful in saving energy as well. And also finally, evaluating actual model performance, for example, energy consumption, and quantifying the benefit of AI in control systems. It's very important. There are a few studies that discuss the problems with using AI for control of thermal comfort. However, most of these studies only rely on simulation, but there is a need for experimental results and something that we can verify our errors in studies. So if there is some experimental method that combined with this simulation and predictive modules, it will complement our studies much more. Finally, the financial costs associated with deployment of AI is very high, especially if you want to use, for example, Internet of Things to really measure humans' carbon emissions or physiological factors. So to wrap up, if you are aiming to work in AI, in human comfort or building industry, I would suggest that you could work in correlating an AI algorithm between human comfort and also building control systems like HVAC systems, set points, and so on in order to save energy and also provide comfort. This is a part that is missing, and also maybe trying to come out with more unsupervised algorithm like or reinforced algorithm which are missing. These are the kind of the gap that you could work on, and also the parts in the steps that you can improve. Good luck and all the best. Yeah.